Hi everyone, for today's lesson we are going to learn more information about the distance formula and review the midpoint formula. For today's lesson you will need the following items. You'll want to have some colors for highlighting. You might need to have a straight edge because we will be graphing some segments. You may need a graphing calculator or any calculator for that matter, something to write with, and your interactive notebook to reference. To start off this lesson, I want to refer back to the interactive notebook. We already talked about the midpoint formula, and now we are on day 6, which is working more with the midpoint formula and the distance formula. These I can statements were to be able to find a point on a segment that divides the segment into many evenly spaced pieces. That is an application of the midpoint formula as well as a little bit of the distance formula. And then of course, I want you guys to be able to calculate the length or distance of a segment given 2 points. So those are going to be our new topics. Our other topics, we are going to talk about those again, calculating a midpoint, calculating an endpoint, and using that definition of midpoint to find other lengths. Now, midpoint, let's do a really quick warm-up. What happens if a segment is not bisected and instead it is divided into thirds or fourths, etc.? How would you find what the length is? So if a segment is bisected, it is cut in half, or you would take the length and divide it by 2. So if it was divided into thirds or fourths, we would take that length and divide it by 3 or 4 or 5 or 6. And that's what I want you guys to write down. So what happens if the segment is not bisected and is divided into thirds and fourths instead? What you would do on the midpoint formula is you would, instead of dividing by 2, you would divide by 3 or divide by 4, etc., depending on what you're dividing by. So let's go ahead and draw what that looks like. Let's go ahead and draw a picture of a segment that is divided into thirds. What would that look like? So let's go ahead and draw a segment. And we need to come up with it being evenly spaced. So I would probably have maybe a point right here, and maybe a point right here. It's divided into 3 equal pieces. And how I know they would be equal pieces is that there would be these tick marks on there. This would be divided into thirds. If I were to draw a segment that is divided into fourths, what would that look like? Well, let's draw a segment and let's divide it into fourths. Well, I would probably need to maybe space it out a little bit. Maybe have like a midpoint and then like a point right here and a point right here. And I would know that it would be divided into equal pieces because I would see tick marks that would match. 1 tick mark, 2 tick marks, whatever the case may be. So if I wasn't interested in the midpoint formula and I was interested in maybe the thirds formula or the fourths formula, what would change in the midpoint formula? Well, what would change is what we're dividing by. We would divide by a different number. Like 3 or 4 in these problems that we just did. We would just divide by something else. And so what you're going to see in the next few examples is that we are going to be talking about going a third or a fifth or other distances other than halfway. And so I just wanted to kind of repair your brain for us not necessarily working with the middle. These types of problems for examples 1 and 2 are problems that are typically on quizzes and tests. And I want you guys to please make sure that you pay attention to them. They may or may not be like something that is necessarily clear right away, but I'm hoping that I can make it as clear as possible. So what you're going to see is a segment on a number line, and you will be asked some follow-up questions based on this segment. Like the first one being, what is the length or total distance of the segment? Now, because we're not talking about a coordinate plane, we do not need to work with the distance formula. Instead, we simply count from one end to the other. So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be the full length. How far is 1/3 of the total distance? How many units would you travel if we were going 1/3 of the total distance? Well, if 9 is the total distance and we want 1/3 of the total distance, that is essentially 9 divided by 3, or 9 times 1/3, which is equal to 3. So you would travel 3 units to go 1/3 of this total distance. Now this is where it gets a little weird. I'm going to put an L right here to represent the left side and a R right here to represent the right side. If you begin at the leftmost point on the segment, what location is 1/3 of the total distance? So I'm not looking for the answer to be 3. I'm looking for where will you land? So I know that I have to travel 3 units because that represents 1/3 of the total distance. So I'm going to start at -3 because that's my leftmost point, and I'm going to travel 3 units. 1, 2, 3. And the location I land at is located at 0. So that's my location, 0. The location of 0 is 1/3 of the total distance starting at the leftmost point. Letter D says, how far is 2/3 of the total distance? Well, let's think about that. What is 2/3 of the total distance? That is essentially 9 times 2/3. So 9 times 2 is 18, and 18 divided by 3 is 6. So 6 units. That's how far you would travel if you were to go 2/3 of the whole distance. Now what they're going to ask of you is, what point is 2/3 of the total distance from the leftmost point on the segment? So we're still starting at the leftmost point, but this time I'm calling it point instead of location. These two words mean the same exact thing. Point and location are the same. Where do you land? So let's go ahead and travel 6 units because that's 2/3 of the total distance. 1, 2, 3, 4, 5, 6. I land at the number 3. All right, here we go. Looking at number 2. Same exact idea. This time around, we want to find what the length or total distance of the segment is, and this time we're working with G to H. Please be careful. Don't just count by ones necessarily. You have to be well, I think in this case it ends up being ones now that I'm saying that out loud. There's other problems where it's not going by ones. So now that I'm looking at it, I think we'll be okay. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 units long. How far is 1/5 of the total distance? Well, 1/5 of our total distance is basically 10 divided by 5. That is 2 units. If I travel 2 units, that is 1/5 of our total distance. So if you begin at the rightmost point, so let's go ahead and label this left and right. This time around, we're going to begin at the rightmost point on our segment. What location is 1/5 of the total distance? So this time around, we're going to travel 2 units, but we're starting at the rightmost point. So traveling 2 units is 1, 2. We land at the number 2. And that's what we would write down, 2. Next, how far is 3/5 of the total distance? So if our total distance is 10, 3/5 of, that word of means times, 10 times 3/5, that is equal to 10 times 3, which is 30. 30 divided by 5 is 6. So 6 units is going to be 3/5 of the total distance. Now what they're asking is what location, which remember location and point, they all mean the same thing. What location is 3/5 of the total distance from the rightmost point on our segment? So we're once again starting at our rightmost point, and we're going to travel 3/5 of the total distance, which is 6 units. So I'm going to travel 1, 2, 3, 4, 5, 6, and I land at -2, and that is my location. That is 3/5 of the total distance starting at the rightmost point. I know this is really weird. I don't mind going through this type of problem over and over again, especially since it's going to be on tests and quizzes, and whenever you see stars, that's something that I want you guys to be aware of. All right, let's go ahead and flip the page. This is our midpoint review. So I want to make sure that I talk about that again. Remember that our midpoint formula, that's going to be equal to our average of our x values, which is x1 plus x2 cut in half, and y1 plus y2 cut in half. And now it doesn't matter if you use the first ordered pair or the second ordered pair, as long as you are consistent. That is the most important thing to note when it comes to the midpoint formula. And notice this time we do not have a graph. So you will be asked simply to find the midpoint given our 2 ordered pairs. And I don't have letters next to them, so that means that we're just going to simply say M, midpoint, is going to be equal to adding our x values. And if it helps you to label, go ahead and label x1, y1, x2, y2. So x1 is -5. Plus x2 is 4, and we're going to divide that number by 2. Then y1 is 8, plus y2 is -7. Always be careful with your signs. Put those plus signs in there. Put those minus signs in there. We want to make sure that we're consistent. So this is going to be -5 plus 4, which is -1 over 2. And 8 plus -7 is 1 over 2. So our midpoint is located at -1/2, 1/2. There's our midpoint. Not a whole bunch of work to show. Next, letter B. Ooh, this is our 2-step or frog hop. We are told, or are asked to find the other endpoint. So the other endpoint, so I don't know what this is. Given that the midpoint is 12, -5, and one endpoint is -7, -2. So I'm going to draw a line so that I show separation, and I'll show option 1 and option 2. Option 1 is the 2-step. Now remember, in the 2-step, you double the midpoint, subtract the endpoint. So our other endpoint, I don't know what it's called. I don't have a letter next to it. I'll just call it B. I can call it anything I want. So that is going to be equal to double the midpoint. So here's my midpoint, and I'm going to work with just my x values first. So this is 12 and -7. So double the midpoint, 2 times 12, minus the endpoint, which is -7. Please be careful with your signs. Comma, double the midpoint, subtract the endpoint. So my midpoint is negative 5, so that's 2 times negative 5. Subtract the endpoint, which is negative 2. Be careful with your signs. Negative, negative. We know that a negative, negative makes a plus. So we're just calling our other endpoint B. 2 times 12 is 24. 24 plus 7, comma. 2 times negative 5 is negative 10. Negative 10 plus 2. So our answer is going to be 31, comma, negative 8. That is our location. Let's go ahead and look at option number 2, which is called frog hop. In frog hop, you draw a picture. And we would put our midpoint in the direct center. We would know that each side is going to be congruent to each other. And this ordered pair, the end point is located at negative 7 to negative 2. Our midpoint is located at 12, negative 5. And we need to find the other end point. All right, so this is where we are going to be working with our x values up top and our y values down below. And we have to ask ourselves the question, how do you go from negative 7 to 12? What do you do? Well, to go from negative 7 to 12, that's going to be 7 plus 12, which is 19. We're going to add 19. So now, how do you go, what is 12 plus 19? So this is 12 plus 19. Well, that's going to be equal to 31. Just below, we're going to be working with our y values. How do you go from negative 2 to negative 5? What do you do? Well, we would subtract 3. And now we're going to repeat that. Going from negative 5 to the next point, we would also subtract 3. Negative 5 minus 3 is negative 8. Like I said in other lessons, I do not care which approach you go with. My goal for you is to get the answer of 31, negative 8. That's what I want you to be able to obtain. Can you do that using one method? I don't care which method it is. All right, let's go ahead and look at example number 4. It says the graph is just for the purpose of giving you a visual idea. So this is just going to be for these problems. For homework, you will not have a graph or have to graph these problems. You'll just plug the ordered pairs into the distance formula and simplify. Whatever you do, don't skip steps. And I need you to please use the order of operations, which is please excuse my dear Aunt Sally, PEMDAS, appropriately. Before we continue, I think it might be helpful to look at that distance formula one more time. So remember that distance is, we use this whenever we're working with an ordered pair. And that distance formula has a square root of the difference of our x values squared and the difference of our y values squared, where we saw in our example that we did where you have to be very careful with your signs. And where we will use our graphing calculator is we'll use our calculator, not necessarily graphing, but we'll use our calculator to come up with our answer rounded to the nearest hundredth. So let's go ahead and put into our notes what that distance formula is. And I'm just going to put it at the very top of our paper over here because I have more space. And that is that D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And we're going to use this formula to find the distance. So first of all, I would recommend strongly plotting these points of R and T. So R is located at 3, 2. And T is located at negative 4, 3. This segment is on a diagonal, which means that we can't simply count just like we did in a few examples ago. You cannot count directly from T to R without using our formula. And our formula, once again, is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. helps you to label R and T, go ahead and do so. So this is X1 and Y1 and X2 and Y2. All right. So I want to find the length of RT, and I'm going to write RT with no line above because no line means we're talking about length. And I'm going to write the square root, and square root has like a little tail at the end. And I have x2, which is -4, minus x1, which is 3, squared, plus y2, which is 3, minus y1, which is 2, squared. So RT is going to be equal to the square root of, and if you want, you can do more than one step in one step. If you find that to be too confusing, that's okay too. But if you were to do more than one step in one step, it would look like this. -4 minus 3 is -7. -7 squared is 49. Plus 3 minus 2 is 1. 1 squared is 1. So my answer is going to be the square root of 50, and I'm going to put the square root of 50 into my calculator. I'm going to press second x squared to get my square root button, and I'm going to put the number 50 in. We're rounding this to the nearest hundredth. The number that's after 7 is a 1, which means I keep it the same. So my answer is approximately 7.07, and that is the length from T to R. Next, we're going to go ahead and look at letter B. We want to find what the length of GH is given these points. If you would like to pause the video at this moment to try this one on your own, please go ahead and do so, and then we'll restart the video to see how well you did. Okay, the first thing I'm going to do is plot these points. I'm going to plot 5, -1, and call it G, and -3, 6. We'll call it H. Using my straight edge, I'm going to connect these 2 points to create a segment. And as you can clearly see, this is on a diagonal, which means I cannot simply count in order for me to find what the length of this segment is. So I need to do that. I need to find what that length is using the distance formula. If it helps you to label, please label x1, y1, and x2, y2. And I'm going to write GH is equal to, notice GH has no line because we're talking about length. GH is equal to the square root of x2, which is -3, minus x1, which is 5, squared, plus y2, which is 6, minus y1, which is -1. Please, 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 please be careful right here with your signs. We have a negative inside of our parentheses. A negative makes a positive. And we have GH is equal to, and I'm going to do more than one step in one step. -3 minus 5 is -8. -8 times -8 is 64. Plus 6 plus 7 is 6 plus 1 is 7. 7 squared is 49. So this equals 64 plus 49, which is the square root of 113. And we're going to put that into our into our calculator. And I end up with 10.63. There's a 0 at the end, which means that I just keep it the same. So I'm going to write 10.63. And there we go. So here's a fun question that connects what we've already talked about before. Are the segments from A and B congruent? Well, do they have the same length? No. So we were going to say no. RT is not congruent to GH, and we'll say because they do not have the same length. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.